Hi, thanks for joining me today. I've got a problem from the Canada Junior Olympiad. We have an n by n grid like so, and we have these tetromino pieces. So these kind of pieces which are in the shape of a T and they occupy 4 squares. Essentially, we want to know is for what values of n can we entirely cover the n by n board with these tetrominos such that none of them overlap and that none of them hang off the edge. So here, this is the case where n is 4 that I've drawn up, and this one is possible. So I can put a tetromino there, a tetromino there, one there, and also one there. So it fits quite snugly like so. And so that proves that it's possible for n is 4. We want to know for what other values of n does this work. If you want to have a go at this problem, pause the video now and give it a go for yourself, and I'm going to dive straight into a solution. Okay, so first things first is we do need n to be an even number. Why is that? Well, if n was odd, then we'd have n squared squares in this grid here, and n squared would be an odd number. But the issue with that is each tetromino occupies 4 spaces, and so that's an even number of kind of squares, and it doesn't matter how many of these tetrominos we have, they're only ever going to occupy an even number of squares. So we wouldn't be able to cover the grid entirely. There'd always be at least one missing. So we need n to be even, and hopefully it's pretty clear to see that in fact any multiple of 4 will work. So if n is any multiple of 4, we will be able to cover the grid. Well, we know it works for 4 by the example I had before, something like this, if our tetrominos are laid out like this. Now, if we just look at 8, for example, if n was 8, we can split the grid into like 4 lots of the 4 by 4 grid. And we know that each of these can kind of be covered with these tetrominos if we lay them out like this. How is it? Something like that. And we can do that for each of the 4, and hence the whole 8 by 8 grid can be covered as well. So the only thing left to worry about is what if n is an even number but not a multiple of 4? So if n is 2, n is 6, n is 10, etc. Can we cover the board then? Let's see. Okay, so it turns out that it's actually impossible when n is even but not a multiple of 4. Here I've drawn the 6 by 6 example, and I'm going to illustrate why it's impossible for this case. Now, the issue is, if n is an even number but not a multiple of 4, that means n is 2 times some number m, where m is odd. Because, of course, if m was even, this would be a multiple of 4. Okay, now, why is this of any interest? Well, let's imagine we did try and cover this with the tetromino. Sorry, we could maybe do this, and then I guess here we might get a little bit stuck if I tried to do that. So maybe I start in some other manner. But the issue is, if I look at one particular tetromino, and we think of this grid as kind of like a chessboard, we'll notice that this square here, let's say that was like a black square, that guy there is black, but the other 3 squares are white. And so we know that any tetromino, if we colour the board as we would a chessboard, would occupy 3 of one colour and 1 of the other colour. So in this case, this tetromino here occupies 1 black and 3 white. But if I drew this tetromino here, this square would be black, this one black as well. And so we'd have 3 black and 1 white. Okay, cool. So now what we can do is call a tetromino black if it occupies 3 black squares and 1 white square, and we'll call it white if it occupies 3 white squares and 1 black square. And so we know the total number of black tetrominos plus the total number of white tetrominos must equal, well, n squared divided by 4. And so n squared divided by 4 is just 2m squared divided by 4, which is 4m squared divided by 4, which is m squared. So we know that the total number of black tetrominos and white tetrominos must equal m squared. So black tetrominos, or I should maybe use TB, so the tetrominos which are black plus the tetrominos that are white must equal m squared, but this is an odd number. And that must mean that they can't be the same number of black tetrominos as there are white tetrominos. So one of these numbers must be bigger than the other. It doesn't really matter which. Let's just say, without loss of generality, it's that the number of black tetrominos is bigger than the number of white tetrominos. But then the issue with that is that means that the number of black squares in our chessboard must be bigger than the number of white squares in our chessboard. But that, of course, is a big issue because you can't have more black squares than white squares in the chessboard. There's exactly the same number of black and white squares, and so we arrive at a contradiction. Therefore, it is impossible to cover this grid with these tetrominos if n is an even number but not a multiple of 4. And therefore, the only way to cover an n by n grid with these tetrominos is if n is a multiple of 4. I hope that solution has made sense, and I hope you have enjoyed this video. A nice little problem, not too difficult, but I think an interesting problem to find on a Junior Olympiad paper. Anyway, thanks so much for watching. I'll catch you in the next one. Have a great day.